Good morning, ladies and gentlemen. Today is Wednesday, September 30th, our last day of September. Okay, let's have ourselves a great day and make the most of it. Now, today we are learning about equations and inequalities on both sides, but we're creating those from words. Okay, so slides 2 through 5 are what you're responsible for today. Here's what they look like briefly. And then at the end is a quick little personal survey about how you feel. It says move the arrow and place on top of the emoji that describes how you feel. Whether you are upset with today's lesson, or you are super happy, or somewhere in between. I ask though that this arrow is a reflection of how hard it was to do the assignment. Okay? So, not just if you like me or like the class. Now, slide 2 through 5 are all similar. It says, can you identify the parts of an equation or inequality? You'll notice it looks very similar to yesterday's activity, but this time we have two sides. Yesterday we focused on creating just one side of finding the parts from one side of an equation or inequality. Today we are focusing on finding the parts from both sides of an equation or inequality. So our first example here talks about some hot chick named Kyle and another hot chick named Andrew. Okay, so it says Kyle and Andrew are racing down the street. Kyle runs 3 miles per hour and gets a 0.75 mile head start. Andrew runs 4 miles per hour. When will Kyle and Andrew be at the same distance? Okay, so here I need to find the rate / coefficient for Kyle. I'll need to find the constant for Kyle. The variable, I need to type the variable or what it's asking me for, and the operation in between. Okay, and I'm going to do the same for Andrew. Okay, now sometimes it's just nothing, and we'll see by getting more practice. So here with Kyle, we're going to focus first on Kyle. Okay, it says Kyle runs 3 miles per hour. Remember, anytime we have a rate, we usually see words like per, each. Okay, that indicates a rate, that something depends on something. So it's a mile per hour. If you ran for 2 hours, you'd be at 6 miles. If you ran for 3 hours, you'd be at 9 miles. Okay, so that's our rate for Kyle. So I'm going to put 3x. But technically 3 miles per hour would be correct. But we're going to put 3x. All right, because we know it's 3 miles, we just don't know how many hours. All right, and he gets a 0.75 mile head start. So that's our constant. That's just a number off by itself, but it's still part of the problem. So 0.75 would be our constant. That's where he starts from. Now, what is the variable in this situation? You could also say, what is it asking me for? Well, it's asking for when will. That's an indicator of time, and that makes sense because we know it's miles per hour. We don't know how many hours he's running. We just know he ran 3 miles in an hour, but we don't know how many hours he's going to run. So our variable in this case is going to be the number of hours, or you can summarize that by saying time. Now in between, if I were going to put these together, what would be the operation in between? That word and, remember we practiced here? I'm going to go ahead and highlight that, or underline, italicize it. The word and means this is a plus word. Okay, so in between these two is the word plus. And that makes sense because if I were going to do the next step, which I'm not, I'm just going to show it to you here so it makes more sense to you. We would put all this together by saying he started at 0.75 and that word plus, he ran at 3 miles per hour. Okay, that would create this side of our equation. Okay, now we need Andrew's side. It says Andrew runs 4 miles per hour. That word per, that's an indicator of a rate, so there's 4 miles per hour. Okay, is there anything extra for Andrew? Any constant, any number by itself, like there was for Kyle? No, there wasn't. So you can leave it blank or put it 0 if you feel like you need to fill something in there. And the variable it's asking me for is still when, or the amount of time. So the number of hours. And the operation in between in this case is not applicable because there's nothing in between. There's no constant. So if you want to put something, you put 0. Okay? But for me, I personally want a blank. But again, if you want 0, you can put a 0 there. So now, on this side of the equation, all we would have is 4x. And boom. So if we were creating our equation, all we'd have is 4x, so there's no operation between. And in here it says, when will Kyle and Andrew be at the same distance? So that word same, we've learned recently, means equation. It didn't say less than or greater than. It said same. So that's going to be an equation. All right. So I'm going to highlight that, and I'm going to make that yellow. So I know it's going to be equation. So we just created an equation. This step here that I showed at the bottom, you do not need to do. I just wanted you to see how it flows. Okay, so that this makes sense. That is what we're doing today. You're following the same procedures for slide 3, 4, and 5. Have yourself a great day. We'll see you in class, hopefully.